Good morning. So today what we are going to do is we are going to practice a proof that uses CPCF, or corresponding parts of congruent figures. Now remember that when you see that what you're trying to prove is that two segments are congruent, it's always good to check to see if you could prove that triangles are congruent. Because if the entire figure is congruent to another figure, then each of its corresponding parts, including the two sides that we're looking at here, will be congruent to each other. So provided I can prove these triangles are congruent, I know I can prove that this side is congruent. So I'm going to use my givens to check if I can prove these triangles are congruent. So first off, I found that angle AMN is congruent to BNM, and I drew that in already in blue, making sure to kind of mark which givens I'm doing. Next, angle A is congruent to angle B, and I marked that in red. So now I have two angles, and I'm out of my normal givens, and I still don't have enough information. Now I know that when I'm stuck, on my theorem sheet it says, what can you assume from a picture? And of course, first it tells us the givens. Well, I don't have any other markings, so I'm really good in that to that extent. But another thing that I can look for are vertical angles, and I do see that I have some vertical angles here, which is pretty nice. But angles don't help me a lot with this problem, because if I'm trying to prove congruency, I can't use angle, angle, angle. And even if I could, this angle here is not the same as like this little smaller one from AM to whatever point this one is here. So I don't even have three angles inside a single triangle. So I'm going to leave that marking in because it is nice to know vertical angles, but it might not help me. So because I'm stuck, I'm going to look for some other things. One other thing that we always look for after vertical angles is we look for reflexive or shared things. And here, if I'm looking at this picture, I can see that there's overlap between M and N, meaning that this side is congruent to itself. Now that can be really useful because now I have a side and two angles. And it's a good idea to maybe look at what triangles you're referring to here. So I know that this angle makes a side here. So really I have a big oblique triangle coming across this direction. I also have a second triangle over here. Again, the large oblique one. And I mean, those do look visibly similar. And if I look at the information marked on this shaded triangle here, B, N, and this side here are all then congruent to A, M, and MN, which means I have angle, angle, side. And as long as I have angle, angle, side, I know that these triangles must be congruent. So I'm going to go ahead and make my proof. First thing I'm going to do is I'm going to make sure that I don't miss any givens. So I know that angle AMN is congruent to BNM. And that is a given. And I'm just going to cross it out because I know that I've done it. It's on my table. I haven't forgotten to use it. Next, I can use angle A is congruent to angle B. Again, it's on my table and now it's confirmed. So I've proven two of my angles are congruent because I have full congruency statements using just my givens. My next statement is about the side. Well, I want to prove that the side is congruent. Well, I know that MN is congruent to NM, and that's a reflexive property because it's shared. So here, please notice that your M and N are corresponding parts here because what would normally be the M angle in this shaded triangle with B is actually corresponding with the N angle in this shaded triangle A. So notice that those are going to flip-flop, so M corresponds with N and N corresponds with M. Well, now I have angle, angle, side, which means I can prove that my triangles are congruent using angle, angle, side, triangle congruence theorem. Now that gives me the statement, of course, that triangle AMN is congruent to triangle BNM. Again, watching my corresponding points. Now, normally we would be done if we were trying to prove that triangles are congruent. But here we are not trying to prove triangles are congruent. What we are trying to prove is that these two sides, MB and NA, are congruent. Well, these are pieces of those triangles. Therefore, according to CPCF, the corresponding parts of congruent figures, MB would have to be congruent to NA because all of the parts that are corresponding in congruent figures are congruent. And that would be the end of our proof because I've given my givens, I've gone through, I've used no definitions that have not already been defined or given enough sources for, and I've reached what I've been trying to prove.